let's go over some simple things you can do to make your game run better in Raylib. The first, and possibly most obvious thing is, don't do more work than you have to, namely with drawing. So basically, don't draw things that you can't see. The process of figuring out what needs to be drawn and what can be ignored is called culling. Raylib doesn't track game objects and thus can't do culling itself. So it's up to you to handle that. The GPU will do what is called clipping on the final triangles and pixels that are drawn, but that is not the most efficient use of its time. It's much better for you to just not draw what you can't see. Here we have a nice little example that is going to draw a map of tiles. We're going to draw 100 by 100 tiles. We're going to give each grid item a random color. We're going to draw it by simply drawing all the tiles in the camera view without problem. If we run this, everything looks fine. We're getting a pretty good frames per second. We can pan around our camera. Everything looks good. But if we go up here and change this to 1,000 tiles by 1,000 tiles and run the game again, we're going to get a different story with our performance. As you can see here, now our performance has gone extremely low. This is because we're drawing all 100,000 tiles. The reason for this slowdown is because we're drawing things that we can't see. We're drawing all these tiles that are off screen. A smarter thing to do would be to use some functions in Raylib, specifically get screen to world 2D, to help us figure out how much of our grid map is visible at any one time. So instead of just blindly drawing the entire map, we're going to use these functions to figure out where our window starts and where our window ends within our camera. Then we're only going to draw that range. If we do that, still with 100,000 tiles, we're back to getting performance. In fact, we're getting better performance now, several thousand frames per second, than we were drawing even just 100 tiles. So this is a significant performance increase by simply doing less in your program. Another important thing for performance is to minimize how many times you change textures or shaders. Every time you change to a different texture or shader, the GPU has to finish up what it's doing and then wait for the new shader or texture to be loaded. This stalls the rendering pipeline and is not optimal. The GPU is much happier drawing a lot of the same thing rather than swapping back and forth between different things. If you have 2 textures to draw and need to draw 10 of each, it is much better to draw the first 10 and then the second 10 instead of swapping back and forth. Here we have an updated example. Instead of drawing colored rectangles, we're going to draw a series of textures for each grid spot in the map. So instead of using a series of colors, we're going to use a series of textures. We load up 9 textures, we fill out our map in the same type of way, and then as we draw, we're going to call Draw Texture Pro. If we run this, we'll see that the performance is okay, since we're still only drawing what we can see, but it is significantly less than what it was with just drawing rectangles. We're drawing a bunch of different textures here. So what we can do to speed this up is move all of our individual textures into one big texture called a texture atlas. We're going to take our textures and place them side by side here and load a single texture file. Then instead of storing individual textures for each grid, we're going to store a rectangle. This rectangle represents the source rectangle of the texture. So for slot number index 0, we're going to pull from this rectangle. Next, we'll pull the rectangle next to it and so on. So now our map contains a series of rectangles. We're still drawing with Draw Texture Pro. We're always using the same texture, but instead we're using a different source rectangle. As you can see, if we run this, the performance is significantly faster because we're never changing textures. This entire map is drawn from one single texture, and that allows the Raylib batch system to batch this into one big draw call and send it to the GPU in the most efficient manner. The last thing we're going to talk about is caching things on the GPU. You want to cache as many things on the GPU as possible. Doing things on the CPU and sending them to the GPU for drawing uses up precious bandwidth between that CPU and GPU and can be a bottleneck in your game. Functions like draw cube, draw circle, and other shapes are extremely convenient, but they all work on the CPU and have to compute all that geometry and send it to the GPU every time you draw them. It is much more efficient to build a mesh and draw that. Meshes are cached on the GPU and do not need to be uploaded to the GPU over and over again. Drawing them is very fast and very simple for the GPU to do. Here we have another example where what we're going to do is draw 500 spheres. So we're going to create a list of spheres, set them as random positions, and draw them by calling draw sphere. As you can see, our performance here is not great. We're getting 14 frames per second, and this is a very good video card. This is because we're having to compute every one of these spheres, every frame, and send it to the GPU. It's not great. If what we do instead is load a mesh and still load up all of the same sphere points, and instead call draw mesh, we get a radically different picture of our performance. Here you can see we're getting several thousand frames per second for drawing the exact same number of spheres. In fact, with this setup, I could increase this by an order of magnitude to 5,000 and get similar performance. This is all because this mesh for the sphere is cached on the GPU and no data has to be sent for all that geometry. All the CPU has to do is tell the video card, draw these spheres at these locations. That's a lot less data and a lot less bandwidth and much more efficient for the GPU. For similar reasons, when drawing 2D shapes, it can often be much better to simply draw a texture with that shape on it than it is to draw the shape. A call to draw a circle requires 72 triangles, where a call to draw a texture only requires 2, because the circular shape data is stored in the texture, and that texture is stored on the GPU. So these have been the 3 biggest things you can do to improve performance in Raylib, or really any GPU-based system. They are easy to implement and just require you to do a little bit of planning. Happy coding!